this is the second part of a two-part lesson. So in this lesson, I will be showing the examples of how to solve and how to write exponential growth and decay when you are given real-life scenarios. I have explained each of these equations in the part 1 of this video. So the first example that I will be dealing with today is asking us to identify whether each of these 6 equations represent a growth or a decay. So just to quickly remind us, so for the exponential growth or decay, we can write it as y equals to a multiplied by b raised to the power of x. So for this, whereas when our b is greater than 1, so we have a growth. And when our b is less than 1, but if b is also greater than 0, we have a decay. So we are just going to look at the equations, compare it to this particular equation and be able to determine if it's a growth or decay. So in this case, for example, A, our B, so A is like A equals to 1 in this example, and B is 1.101. So that means it's greater than 1. So this is a growth. Okay, the system is not behaving. So example B would be a decay because you can see clearly that our B in this case is 0.033. In this case, our B is 2, so this is a growth. And in this case, our B is 0.5, so that's a decay. And in this case, this is a case of growth, and this entire 1 plus 0.025, that's our B, okay? So this is a growth. And for the final example, for this question, this represents a decay because when you subtract 0.4 from 1, you get a number that is less than 1, okay? So that represents a decay. So in this example too, we want to be able to write a multiplier when you are given the growth percentage or the decay percentage. So in this case, you can see that our growth percentage, we represent that with R, and our multiplier, we are representing it with B. Okay, so our growth percentage in this case is 5%. So it's going to be 5 divided by 100. So that's 0.05. So whereas the multiplier will now be, so multiplier B, if it's a growth, is 1.1 plus R. So this is going to be 1.05. Okay. So for the example 2, that's a decay. So our multiplier is still 12%. So that will be 12 divided by 100. That will be 0.12. And for this case of a decay, our B will be 1 minus R. So in this case, 1 minus R will be 1 minus 0.12. So that will be 0.88. So our B in this case is 0.88. So this example says, dinner at grandfather's favorite restaurant now costs $25. So the cost has been increasing. So this cost has been increasing. So that tells us this is a growth. It's not a decay. So it's increasing at the rate of 5% each year. So again, it is definitely a growth rate of 5%. So 5% is 5 divided by 100, which is 0.05. So that means our multiplier in this case is going to be 1 plus 0.05, which is 1.05. Okay, so what is the equation for this scenario? So the equation for this scenario is going to be f of x equals to the starting value, which now is $25, multiplied by 1.05 raised to the power of x. So now the question says, how much did the dinner cost? How much did the dinner cost 30 years ago? So 30 years ago, that means we want to go back 30 years. So x will be negative 30. So to solve the question and to answer this particular question, so we are going to evaluate this function at negative 30. So that would be 25 1.05 raised to the power of negative 30. And if you type that into your calculator, you're going to get, so you're going to get, so it's 25. So you're going to get 5.78. Okay, so that means dinner cost $5.78 30 years ago at the favorite grandfather's restaurant. So the final example in this lesson, so each year this local country club sponsors a tennis tournament. So at the start of the play, there are 128 participants. So during each round, half of the players are eliminated. So when you eliminate something, so it decreases. So that means we are dealing with a decay in this case. So what is the multiplier? You can see that instead of you begin, you are not in this particular questions, we are not given any rate. We are just given like half of the players are eliminated. So that means you are given the multiplier. So this is the B. So that means our B in this case, okay, is 1/2. So write the equation. So the equation for this scenario is going to be f of x equals to, so because we are starting with 128 players, okay, and we are multiplying with half raised to the power of x. So how many players remain after 5 rounds? So that means our x is 5, okay. So to solve the question, we want to evaluate the function when x equals to 5. So that means we want to calculate 128 multiplied by half raised to the power of 5. So if you put that into your calculator, f of 5 will be 4. So that means after 5 rounds, there are 4 people or 4 participants remaining after the 5th round of the tournament. And that is the answer. Thank you.